Hello everyone, I am Dr. Sonal Jain, Department of Anthropology, University of Delhi. In this lecture series of forensic science, we will be discussing about various tools and techniques used in forensic investigations. In our previous lectures, we have discussed about the proper collection and packaging of evidences is being done. A meticulous evidence collection is the need of the hour so that the proper analysis of the evidences can be done. In this lecture, we will be discussing various evidences, how they are being analyzed in various divisions of forensic sciences. In the question documents divisions, we usually analyze the various forged handwritings or various checks on which various alteration, obliteration, etc. is being done. For the analysis of such documents, the documents analysts use certain magnification tools, for example, magnifiers or microscopes. Document examiners use a wide range of magnification equipment, which includes handheld magnifiers, which can enlarge the material from 2x to 10x, and they may have the lightening abilities so that the field of view is being brightened. So, document division certainly have certain cases where there are certain checks in which there is an addition of number, or there might be certain handwriting where the other person might have tried to forge the signature of another person. So, basically we need certain magnification to know if there are certain tremors which are present in the handwriting of that person, or we have to look for certain additions, obliterations, which can be done through a different ink in a check. For example, in certain cases, if a check is being written for 1000 rupees, but the criminal might have added an extra zero and make it to the 10,000. So, that extra zero can be identified using various light sources. Most handwriting examination is done at the power of either 10x to 50x, and the subject is enlarged 10 to 50 times for proper identification. In the magnifying glass can be used for the examination of forged documents. We can enlarge our handwriting to 10x, 15x, 20x and 25x, which can give us a clear picture that while writing this, either the flow of writing is being maintained or there are certain tremors which are present in the handwriting, which can give us an idea that this might be a forged handwriting. Video spectral comparator, also known as VSC, it is a integrated composite system which comprises of various cameras, light sources, that includes infrared light, laser light, UV light and filters, which help us in the comparison of question documents. This is a very handy instrument where we can put our question sample or the question document inside the machine, and through the use of computer screen we can see, we can enlarge the particular area, we can change the sources of light, and we can analyze any document, any forged passports, any forged currency keeping inside the VSC. The best part of video spectral comparator is it is a non-destructive instrument. Whatever document or whatever evidence we have to analyze can be put directly into the video spectral comparator, and we can choose from different options that we have to choose the UV light, we have to choose the IR light, we have to choose the laser light, we have to choose the magnification of 50, 100, 200, etc. And the area also can be chosen, because we can select the particular area that we have to examine or we have to magnify this particular area. It helps us in the detection of alterations, obliterations, erasures and page substitution. Alterations is like if someone has written a check of 1800 and they are making the 0 to 8 or adding more zeros or changing a number, that is alteration. Obliteration, if someone cuts over the handwriting and write again. Erasure is using any chemical erasures or physical erasures to remove one point and adding another point. Or page substitution, in some power of attorney or wills, there could be some substitutions in that. That can also be examined using the magnification power or the light sources of video spectral comparator. There are various VSC available, VSC 2000, VSC 5000, etc. Depending upon the advancements, they have more advanced sources and they help us a question document analyst to analyze the proper evidences under the light of it. We can also look for if someone has tried to forge their passports or tried to forge the stamps or the visa, then we can analyze and see whether the microprinting is present over it or not. So, on a computer screen, we get the full view of what is inside the VSC. VSC is also used to analyze inks and see whether they are the same or different inks. Document examiners look at them under different lighting conditions where some wavelength of light are blocked. We can choose, if we have to analyze a red light, then we can block the red wavelength light and see whether this particular thing is written with some alteration or obliteration. We can also uncover layers in documents where words have been scribbled out or written over the another word. Alterations, obliterations and erasures are not visible to the human eye and can often be detected through use of photography and other imaging devices that utilize UV and infrared wavelength of light. Using radiations filtered at various wavelengths can reveal the handwriting which is beneath it and that has been added with a differenting or has been altered or removed by exploiting variations in the way different inks respond to different wavelengths of light. For example, if a check is being written, we can see that the August and the 11, we have added, a number has been added with a differenting, the name of the person, and the 6 has been changed to 16. So, in the UV light under the VSC, we can see that a variation in ink has been observed. If you will see this check with normal radiation in the normal light, it will look similar that it is written with a blue pen. But when it is being analyzed under video spectral comparator, under the variation of different wavelengths, you can see that the addition and obliterations has been done or the alteration has been made with this particular check. The VSC has different light sources which are used to help bring out specific types of features in the question document. They have the incandescent filament lamps which have a range from 400 nanometer to 1000 nanometer and it can encompass proper visible and IR light vision. The VSC offers 3 ranges of UV light: 365 nanometer, 312 nanometer and 254 nanometer. Also, our Indian passport has different wavelength characteristics. If you will observe the passport under the different wavelengths of UV, you will see different colors. So, if a person tries to forge the passport, you can clearly see and locate that this person has done some forgery because the particular colors are not visible at different wavelengths of UV ultraviolet region. All of these can illuminate the document from above, as well as we have the option of transmitted light in the VSC which can offer UV light with 365 nanometer. Another source which is present inside the UV VSC is a flash tube which has a range of 850 to 1100 nanometer and is used for the anti-Stokes flash function. With a UV source light, if there is any secret handwriting written with any chemical material, for example with the lemon juice, some handwritings can be written, then they are visible either under the heat or under the light sources. There are certain question document problems where we have to identify the indentations. Supposedly, if a person has written something on the front paper and he has stored away that front paper, but there can be certain indentation marks which are being transferred the second, third, fourth and fifth pages. There is an instrument which can identify those indentation marks, and that instrument is ESDA, electrostatic discharge apparatus. Electrostatic detection apparatus is a special instrument which is capable of restoring handwritten impressions in paper that are completely invisible to the bare eye, but if we use ESDA on those devices, then we can able to make out what the indented writing is. It can also be used to detect footwear impressions on any paper items which are latent or not visible to the naked eye. The ESDA consists of a toner, a laminated sheet where we can keep the piece of paper on the top of it, and we have to electrically charge it. Then we can laminate it, and a layer of toner will deposit on the paper on the indented marks. The apparatus is used for decipherment of the indented writings. Surface of the paper causes a different pattern of charging in those areas where there are indentations. So, the indented area have different charge, and the area which is not indented have a different charge. So, this charge variance is visualized by spreading over an oppositely charged black toner powder, and the document to be examined is positioned on the instrument and covered with a sheet of transparent film. The film and the document are then exposed to the charge, and the charge dissipates rapidly, excluding those areas where indentations are present. And the ultimate stage comprises of putting on black toner to the exterior of the film which stick to the charged parts, making visible the indented writing evident. The examination of documents for indented writing impression is very important and can yield a lot of information that had been misplaced, destroyed, and no longer available. In fact, in the cases, the indented writing can be deciphered up to second, third, fourth, fifth, sixth page. As we can see in this image that the top page was original with the writing clearly, but as we have gone down on the first page, second page, third, fourth, fifth, the indentations of the writing is clearly visible because of the use of ESDA instrument. A lamination sheet was covered on this document, and then the pages which were not visible to the naked eye, the handwriting was not visible to the naked eye, but ESDA has properly toned over to the documents which are indentations were present on those documents. Another major technique which is being used in the question document revision is the stereo microscope. The stereo microscope is an optical microscope arrangement which is designed for low magnification observation of a sample using reflected light sources in an object other than transmitted through it. The stereo zoom microscope is different from comparison microscope because it has two separate optical paths. So, there is an angle through which we can see the evidence which creates a 3D image. The stereo zoom microscope is being used for the analysis to know about the sequence of stroke. This arrangement produces a 3D visualization of the sample which is under examination. As we can see, the parts which are dark, they are on the top, that is that sequence of stroke is being written afterwards, and the light, the part which is being lighter, it is written before. So, through using stereo zoom microscope, we can easily identify that which parts are written before and which parts are written after. The sequence of stroke can be analyzed using stereo zoom microscope having a 3D image. Another major problem which is being faced by the scientists in the question document analysis division is the analysis of ink. The analysis of ink is very important because in various examination, in various forgery, the criminal might not have the same ink or same pen as through which the victim might have wrote. So, the ink analysis is a very important factor. If a check is being written by the victim and the criminal have made some changes in the check or in any other document, the ink is different, although it appears to be blue in color, but different brand inks have different composition which can be known that this particular blue ink is different from the blue ink which was written before. So, in such cases we use a Raman spectrometer, which has been shown to be a very promising technique for the forensic analysis of inks in question document analysis. This technique provides a chemical signature for each ink. So, basically ink is a chemical substance which composed of various products, and different brands of the ink, they add certain amount of chemical to identify their ink from other brands. So, this chemical signature of each ink facilitates the comparison and allow us to discriminate between different samples of the ink. Along with Raman spectrophotometer, we can also use TLC, thin layer chromatography, because the ink components can also be separated via thin layer chromatography, where we can take a piece of thin silica sheet and we can run samples, ink samples on those plate of thin layer chromatography sheets, and we can see that at various points we can calculate the RF factor, retention factor, and we can analyze or we can discriminate between two or different types of inks using the Raman spectrometer or using thin layer chromatography. In Raman spectrometer, we have various laser excitation wavelengths are available and which can provide us the complementary information about the composition of ink. However, there is one more factor, that the fluorescence that the paper or many ink exhibit, that can hinder the results of Raman spectrometer. A Raman spectrometer helps us in the analysis of various ink, where we have to dilute the ink sample taken from the paper, and then we have to put the samples and look for the peaks. So, different peaks can be seen visible in the Raman spectrometer, and we can say that the composition of first, second, third, fourth ink are different, or second and third are matching with the same, which can help us is knowing the brand of the ink. Then we have the physics division. There are certain variety of samples which goes to the physics division. The major samples are the sound analysis, the glass samples. The glass is one of the evidence which is found at various crime scene, because the point of entry may have certain glass fractures, certain glass evidence, or if there is any shuffle between the victim and the criminal at the crime scene, there can be glass pieces found. Also, in the cases of hit and run investigation, we have glass pieces from both the vehicles which is being hurt and the vehicle which was used to make the accident. So, the glass is one of the evidence which goes to the physics division. Here fiber examination is done in the physics division. We have soil analysis in the physics division. Glass is repeatedly encountered in number of crimes such as house break, traffic collisions, homicide, sexual assaults, gunfire incidents, arson, etc. Consequently, during investigations, glass forms one of the evidentiary materials in many criminal cases, and it is a very important evidence which help us in identifying the vehicle in the cases of hit and run. The flakes of broken glasses, window panes may be lodged in suspect's garments, and those glass pieces can be taken from the suspect garments or shoes during the act of burglary or crime. If we look the shoes of any suspect, there might be certain small flakes which goes inside the base of the suspect shoes. In the act of burglary or crime, particles of headlight glasses may be found at the crime scene, which may offer indications that they may confirm the identification of a suspected vehicle. A forensic glass examination is typically comparison of two or more glass fragments in an attempt to determine if the origin of these glass sources is same or different. Less frequently, it is a question of determination of end use or glass provenance. Glass examinations are commonly conducted by refractive index measurements by the application of refractometers. A refractometer is a laboratory or field device for the measurement of an index of refraction. The refractometer is being used for the analysis or to knowing the refractive index of 2-3 different glasses. If a glass is from a different source, then it will have a different refractive index. A conventional glass will have a refractive index of around 1.5, whereas a different high refractive index glass, M100 series glass, will have a refractive index of greater than less than equal to 1.8, which is having a high refractive index. So depending upon the from which area or from which origin the glass was being originated, we can identify it using the refractive index of that glass. If the glass comes from a window pane, it will be a different glass. In fact, in the case of hit and run accidents also, the glass from the window pane of a car will be different, from the front glass will be different in the car. If it is from a truck, the cars will be different. So depending upon from which area or from which origin the glass might have come, they will have different refractive index, and on that basis we can easily identify the origin of the source of those glasses. Whenever we have found glass evidence at the crime scene, if they are present at different locations, then the investigating officer should pack those glasses from different surfaces in different packages. For example, the location 1, which is near to the window, location 2, which is near to the door, or location 3, which is in different room, so that those glass pieces can be matched with their source. Thinking that the glasses are found at a single crime scene, they might be from the same source, would be a big mistake. That is the duty or responsibility of a forensic analyst in the physics division, to know whether they come from a same source or not. Refractive index analysis of a glass is a non-destructive procedure and will give us a preliminary idea. If they have different refractive indexes, then they are from a different sources. Another important instrument we use in physics division is scanning electron microscope. In various cases we encounter the paint samples. Mostly it could be found at the hit and run cases. The paint samples is composed of different layers, and scanning electron microscopy can be used to know the different layers of the paints. SEM is used for observation of specimen surfaces. When the specimen is irradiated with a fine electron beam, the secondary electrons are being emitted from the specimen surfaces, and that is being captured. The topography of the surface can be observed by a 2D scanning of the electron beam over the surface and acquisition of an image from the detected secondary electrons. SEM requires an electron optical system to produce an electron probe, a specimen stage to place the specimen, and the electron detector to collect the secondary electron, which will give us an image. We require a vacuum system to make the inside of the microscopic column and the space surrounding the specimen are kept at vacuum. A SEM exam in each condition where any sample is being analyzed under scanning electron microscopy, a proper preparation of the sample is being required. This is a picture of SEM and EDX, the scanning electron microscopy. The picture is showing the various layers of paints. Different vehicles or the different surfaces have different coating of paints. So through SEM, whenever we receive a picture, we can see how many coats of paints are being present and what is the thickness of different layers. A paint sample is being analyzed under SEM, and which can locate the original source from where this particular paint has come from. Usually SEM is being linked with EDX, energy dispersive X-ray analysis, which will give us peaks and will let us know what is the composition of different paint layers, as we can see the picture alongside. So this is a combined picture of SEM plus EDX. Another important evidence which is being analyzed in the physics division is the sound analysis. As we know, and we can identify different people with their sound. So sound of different people or the voice of different people is different. It is highly useful in cases. Nowadays the cybercrime is at the peak, and if we have recordings of certain phone or cyberbullying is there, or if some extortion is being done on phone, then those voice recordings can be analyzed in the physics division of the forensic science lab. A sound spectrograph is an instrument that separates the incoming light according to the wavelength and records the resulting spectrum in some detector. The sound spectrograph, an automatic sound wave analyzer, is used for the analysis and classification of human speech sounds and in the analysis of treatment of speech and hearing disorders. The analog sound spectrograph samples energy levels in a small frequency range from magnetic tape recording and marks those energy levels on electrically sensitive paper. This instrument is then used to analyze the next small frequency range in samples and marks the energy levels at that point. So basically, if whatever the recording is being done, we look for the various frequency ranges in the sample and the energy level at that point. That is what makes the sound of different persons different, or the voice of different persons different. This pattern is repeated until the entire desired frequency range is analyzed, and for that particular portion of the recording, the energy levels and the frequency range of the samples is being analyzed through the instrument of the sound spectrograph, which will tell us that the voice sample of these two persons will match or not, where we need a control sample which we can collect from the suspect and the sample which is being recorded by the victim. The finished product is known as a spectrogram, and it is a graphic depiction of the patterns in the form of bars or formants of the acoustical events during the time frame through which this sound is being analyzed. Another important instrument which is being used in physics division is energy dispersive X-ray fluorescence, also known as EDX or XRF. This instrument is being combined with other microscopic techniques, for example scanning electron microscopy, and helps us in resulting of certain peaks. These peaks are also the fingerprints of those particular elements, where we can know, yes, this particular substance, from the example the paint sample or the hair sample or the fiber, has these particular fluorescence. So we can match it with the library and it will give a certain peak which will help us in identification of that particular fiber sample, paint sample, soil sample, etc. This technique is non-destructive analytical technique which is used to determine the elemental composition of materials. It is based on the emission of characteristic X-ray radiation. When a sample is exposed to exciting radiation from more energetic X-ray, this spectra displays as intensity versus energy or wavelength. We can see in the energy dispersive X-ray analysis that the composition of the particular paint sample is composed of which all elements, and these all elements will make the paint sample unique. The presence or the quantity of the calcium in that, magnesium or the lead in that particular sample, the energy dispersive X-ray peaks can help us in individualizing the particular sample. If that is a paint sample, if that is a fiber sample, what is the composition of the sample, what are the elements present in that particular sample. So in the physics division, we can encounter various other samples, for example soil samples. The soil samples can be collected using the footwear of any person. The footwear samples can result, it will be different from different areas. So the footwear samples, if it is from location 1 or if it is from location 2, they will be different. The investigating officer should collect the soil samples from different locations in different packages, and these soil samples can be analyzed in the physics division using the density gradient method, where the different soils of different densities will level accordingly depending upon from which location they are from. The analysis of each and every sample in every division is as important as they are being collected. A proper collection is required in the field of forensic science, as well as a proper analysis where we have to look for the preliminary investigations as well as the confirmatory techniques. Only after the confirmation of the results of such samples An investigating officer who has done the proper collection and the forensic analyst who has done the analysis will give his report in the court and present his case in the court of law for proper justice. Thank you.